Before going into the MOSFET driving ICs, let's first understand the MOSFETs, how the MOSFETs are voltage driven, unlike the BJTs which are current driven. So we can see the simulation here where you can find that while the voltage is given here, you see there is a voltage appearing here, and that is a positive voltage with respect to source. The voltage should be positive with respect to source, and then only the MOSFET switches on. And there is a voltage drop across this depending on the RDS, that is resistance between the drain and source. BJT11 has a very high RDS, that is why you find a voltage drop about 1.8 volts. But actually, if you use Z44, it has a very low RDS, and in the process this will be very low. So that's besides the point. But then what we see here is the voltage. This is a voltage driven device, and this is the N-MOSFET, and we will see how it behaves with another MOSFET which is called a P-MOSFET. In a P-MOSFET situation where we give a between the gate and the source a negative voltage, this is what we see here. A negative voltage, then only the load is switched on. This is what is the difference between the P-MOSFET and the N-MOSFET. Now let's try to understand the MOSFETs in bridge configuration. Here we have two N-MOSFETs in a half bridge configuration where the drive has to be given here to the gate with respect to source, that is positive drive. Here also same thing, positive drive. But at a time we cannot give the positive drive to both, because in that case supply will get short circuited. So when this is high, this is low. When this is low, this is high. In the process, this power flows this way, and the inductor, whatever charges, comes back this way. So that is how an AC flow takes place here. In a half bridge situation. In a full bridge situation, what we have is we have four N MOSFETs where two MOSFETs are having ground reference, that is S, the source is ground. Here these two MOSFETs, the upper two MOSFETs, do not have ground reference. So we have to give a drive with respect to source at the gate, that to positive supply. That means now supposing you want to switch on this load, AC load, how the current will flow? This will flow this way and then passes through this, and this switches on, and that is how the current flows to the negative. So what we have to do? We have to give positive pulse here and positive pulse here, then only these two switches on. And similarly, when this is off, these two switches on, and that is how we get positive pulse here, and it works. But the problem here is that these two do not have ground reference, that I said earlier. So we have to give drive with respect to this, with respect to source. Here also with respect to source. There are certain arrangements which are made by using an IC, which we will discuss later. So the MOSFET, N-MOSFET, what you find, the arrow is inside. When you see the arrow is inside, then these are N-MOSFETs. Now let's talk about the P-MOSFET. We have seen the P-MOSFET and N-P-MOSFET. P-MOSFET has to get some negative drive, and the N-MOSFETs get positive drive. Now let's look at this bridge. Here there are two N-MOSFETs which have a ground reference, but there are two P-MOSFETs because the arrow is outside. When the arrow is outside, you find when the arrow is outside, these are P-MOSFETs. So we have to give gate drive, gate with respect to source, that to negative. Here also negative. But the flow again is the same. When this switches on, this has to switch on, but the supply flows this way. And when similarly, when these two are off, these two are on, and the supply flows this way. But the drive here is different in terms of the upper drive has to be given here. The gate has to be always with respect to the source. So we have to give some arrangement, make some arrangement here how to give a positive supply here. Because it is as usual, the N MOSFETs have a ground reference, so that is absolutely no problem. So we'll discuss this while we go into how the ICs are used to drive the MOSFETs for such kind of applications.